Okay, folks, just to give you a recording notice that all the classes are being recorded. If you have any concern, you need to drop an email. Okay. So what we are going to start today is the random variable. So we have September 15th today. Now the definition of the random variable is random variable is a function that associates a real number. I know my handwriting is not that good. It just I didn't practice on this new annotation tool I have. With each element of a sample space. Okay, so how we define random variable? Random variable is a function that associates a real number with each element of a sample space. Now we need to define here what does the sample space means. A sample space or in some of the textbook you will find the name as the sample description. All outcomes of a random experiment. Okay, so we define random variable, then we find out a word which is the sample space. So we define the sample space or the sample description space is the set of all outcomes of a random experiment. This is L. Now we need to define what is the random experiment means here. Guys, could you please turn off your microphones? So a random experiment is an experiment Okay, I think this is better now. Can you hear me? Okay, perfect. So I just mute every one of you. Whenever I will ask you a question, I will turn that on. It's better, I guess. Okay. Now, okay. So we need to define the random experiment here, and random experiment is an experiment in which the outcomes cannot be predicted with certainty. So outcomes cannot be predicted with certainty. Okay. So for those of you who are joining now, we started with the random variable. A random variable is a function that associates a real number with each element of a sample space. How do we define the sample space? A sample space, or the sample description in some of the textbook, you will find out the name, is the set of all outcomes of a random experiment. A random experiment is defined as an experiment in which the outcomes cannot be predicted with certainty. Now, a random variable, how we denote a random variable? A random variable is denoted by an upper case letter, such as capital X. Okay, most of the textbook use a capital X, but you can also use capital Y or capital Z, whatever. Now, after an experiment is conducted, the measured value of the random variable is denoted by a lowercase letter, such as x, small x. If you're reading capital X, then it will be small x. Okay. So if I want to summarize so far, the random variable is what I denoted as capital X, whereas the values of random variable is noted as the small x. Okay. Now let's take an example. So for example, we toss a coin three times. Now you know that for a coin, basically you could have the two possibilities. Either we can get a head or we can get a tail. Now because we are tossing this coin three times, we can have some possibilities here, or the outcomes. The first possibility could be I can get head, head, and head. Okay. The second possibility could be I can get head on one coin one time, then I can get head, and then I can get tail. The third could be outcome could be head, tail, and head. Then I can get tail, head, and head. Then I can get head, tail, and tail. I can also get tail, head, and tail. Other possibility could be I can get tail, tail, and head. And I can get tail, tail, and tail. Okay. So all are these the possible outcomes. That's what we called as a sample space. So if you want to write down it as a sample space, you just write down S and you use this middle bracket to denote them. So these are the possible outcomes when I toss a coin three times. Now let's say we define the random variable as the number of heads in each test. Okay. So what is my random variable here? It is the number of the heads in each test. Now, so what could be the X values basically? It could be 0. It could be 1. I can get 0 head. I can get 1 head. I can get 2 head. I can get 3 head. Okay. So 0, 1, 2, and 3 are my number of the heads in each test, which is my random variable. Now, if it is 0, it will be denoted as the x0. If it is 1, it is noted as x1. If it is 2, it is noted as x2. If it is x3, it is noted as x3. Okay. Now, what does the random variables do basically? The random variables maps our sample space, which is S, into real numbers. By that I mean to say they quantify the possible outcomes. Okay. Now let's find out the random variables here. So we can say that I want to find out the value of x is equals to 0. Now by x is equal to 0, I mean to say there is no head when I toss the coin three times. So what we will do here, I will go on my sample space here and I will try to see where I don't have any head. So I do have the head here in this I can't take it. I do have the heads here. I do have heads here. There is a heads. There is one head. Again, there is one head. There is one head, but there is no head here in your possibility where we have the three tails. So what will be my random variable x here? It is will be, this is the set of t, t, and the t, and it is denoted as p, which is the probability that we have x is equals to 0, and this is only 1 here. Now then we look on my sample space. How many total we have? I have 1, I have 2, 3, 4, 5, 6, 7, and 8. So I have 8 possibilities here. Out of these 8 possibilities, 1 is the only where we don't have any head. So what will be my probability? Probability will be equals to 1 over 8. Okay. So this is the probability when I have x is equal to 0. Now let's do it for x is equal to 1. By that I mean to say there should be only one head. So I can't take this because it is more than one head. I can't take this. There is more than one head. There is more than one head here. There is more than one head here. Now this I can take it because it's only one head for x is equal to 1. This I can take it, and this I can take it. So the probability or x is equal to 1, the possible outcomes which has one head is the h, t, 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 h, t, 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 and h. Okay, and now if I want to find out the probability again, what I will do, probability of x, which is my random variable, when x is equal to 1 is equals to, I know that there are 3 possibilities, so it will be 3, and the sample space remain the same, which is 8. So it will be 3 by 8. Now similarly, I can find out for x is equals to 2. If we go back here, we need to see where we have 2 heads available. So this is the possibility that we will use, 1. This is the possibility that we will use, and this is the possibility where x is equal to 2, means there are 2 heads. The rest of them don't have 2 heads. So I come back here. What are my possibilities here? This is the HHT, HTH, and TH and H. And if I want to find out the probability will be x is equals to 2. I know that there are 3 outcomes here. So it will be 3 by 8. Now let's come and see what will be for random variable x is equal to 3. So by that I mean to say there are 3 heads here. So if you look on your sample space, this is the only possibility where you have 3 heads. So I can say this is H, H, and H. And if I want to find the probability, it will be x is equals to 3, and that is equals to 1 by 8. Okay. Now let's take some other examples as well. So it could be an electrical component and the electrical component is tested. Okay, let me just erase this. Okay, so another example is the when electrical component is tested. So we could have two possibilities. One could be either it is defective or it could be non-defective. Because this is my sample space, so I just assign it as the S. So for example, if it is defective, I assign it a 0 random variable. If it is non-defective, I assign it a 1. So by 0, I mean to say it will pass the test, and by 1, I mean to say it will fail the test. Okay, so your random variable could be 0 and 1. Now, random variables, they are classified into two types. So one is called as the discrete random variable. The second type is called as the continuous. Now, this discrete random variable is defined as a random variable is discrete if it can assume finite or countable infinite value. Okay. In other words, or in a very layman language, we can say a discrete random variable is a random variable that can take on distinct or separate values. So basically something that you can count on. Now in terms of the continuous random variable, a continuous random variable is a random variable with an interval. Now this interval could either it can be finite or it can be infinite. of real numbers for its range. Or I can say in a very layman language, a continuous random variable is the random variable that can take on any value in a range. Okay. Now when I say, let's take some examples. Okay, so now let's take some examples here. So on this side, I have the examples for discrete random variable, and this side I have the examples for the continuous random variable. Now in terms of discrete, we just did some examples of the head and tail, if you remember. So these are called discrete because we can count them. Now another example could be number of students in the class. So you can count them, number of students in a class. Okay. Another example could be if you go to the supermarket and buy some apples. So maybe it's 10 apples you buy them. So you can count them. Okay. Now in terms of the continuous variable, this is something that is in the range. For example, if I give it a name of the y as the random variable, I say that the exact height of people in St. John. Okay. Now we know that this height will be starting from 1. It cannot be 0, of course. So 1 will be very tiny guy, I guess. So let's say it is starting from 1 foot, and it is going, let's say, like 7 feet. Okay. So the height here can take any values for the people. But again, let's say someone has the height of, let's say 3.1. Now again, this can be 3.1. It can be 3.12. It can be 3.123. Okay, so it will be keep going here. This is the continuous because it's coming in terms of the range actually from 1 to 7. The practical examples are the mass, basically. Time is an example of the continuous random variable because time can take any value between 0 to infinity. Similarly, the weight, density, temperature, pressure, volume, all these examples are for the continuous random variable because we cannot count them properly. Another example for the discrete random variable could be the number of people let's say born tomorrow. Okay. We can count them. So this will be the discrete random variable. Now, depending upon either we have the discrete random variable or the continuous random variable, we have some specific definitions for probability distribution. Probability distribution. Okay. Since each value of a random variable represents an event, a probability value, probability a probability value can be assigned to each value of a random variable. Okay. Since each value of a random variable represents an event, a probability value can be assigned to each value of a random variable. The probability distribution of a random variable, let's say x, is a description of the probabilities associated with the possible values of x. Okay. So I can say that the probability, this is your x random variable, will be small x I, that is equals to f of x of I. Now, if we are dealing with the discrete variable, this thing is what we call as probability mass function. Or we say it as the PMF. You will see me, I'm saying all the time PMF. Okay. Now let's come back to our example that we were doing before. We find out some random variables. If you remember, for x is equal to 0, we had the possibilities of only t, t, and t. And we find out its probability x is equals to 0, which was turned out to be 1 over 8. Now that 1 over 8 is what we represent as the PMF, and we write it as f of 0. Similarly, we have probability when x is equals to 1. This is represented as f of 1, and it is written as 2 by 8 that we find out earlier. Similarly, probability of x is equals to 2. We have f of 2, which was 3 by 8. And the probability of x is equals to 3. We write it down as f of 3. And this is equals to 1 by 8. Now the way you represent this is you draw the table actually. So this is my random variable x, and you just draw the line. And you write down your f of x. This is my 0. This is my 1. This is my 2. This is my 3. So for 0, we know that this is 1 by 8. For 1, I know it is 3 by 8. For 2, I know this is 3 by 8 again. And for 3, I know it is 1 by 8 again. Okay. So this is how you denote your PMFs. Now there is a thing that we call as cumulative distribution function. Or most of the time you will see me saying that CDF. That's the abbreviation of cumulative distribution function. Now cumulative distribution function is denoted by uppercase F with the x, and this definition is it is the probability that your random variable will be less than or equals to x of n. Now by that I mean to say I will have the probability at x is equals to x naught plus the probability at x is equals to x1, and plus it will be keep going until we have the probability of x is equals to x of n. Okay. Now we just look, if I go my previous slide, we just find out that we denote this probability as f of that random variable. So this I can write it down. This thing I can write it down then f of x0 plus this will be f of x1, this thing, and plus it just keep going up to the this thing I can write it down as f of x of n. Now if you note down here, I'm adding up all these terms, so I can write it down that this is the summation of f of x of I. And what is the range of my I? I will be starting from 0 as you can see here, and it is ending on n. So it will be from 0 to n. And that's what is the definition of the CDF. Okay. Okay, this is better. So this is called as the CDF, Cumulative Distribution Function. Now, there is one thing which is called as the complementary cumulative distribution. This is denoted as C, C, and D. Now, the definition of cumulative complementary cumulative distribution, first it is noted by f of x of n, and we just put a bar on this. This is equals to p x of n. Okay, and it is taken as in the similar way. If you do like I did before, this is defined as summation from I is equals to n to capital N, or in other words, I can take it as 1 minus of my CDF, f of x of n. That's what is the definition of your CCD, complementary cumulative distribution. Now the PMF and CDF that we just discussed, those can be represented as those can be represented on the bar diagram. And how we draw that diagram? If we go back to our previous thing, we know that Px is equals to 0. It was 1 by 8. For Px is equals to 1, it was 3 by 8. For Px is equals to 2, it was 3 by 8. And for Px is equals to 3, the value was 1 by 8. Okay. So we draw our graph here. Now on the x-axis, I have my random variable values. So this is could be 0, this is 1, this is 2, and this is the 3, let's say. Now on the vertical axis, I'm going to take my PMF, or which is the f of x value basically. So for x is equal to 0, I know this is 1 by 8. So for example, I go from here up to this point is 1 by 8 on the graph. For x is equal to 1, I know this is 3 by 8. So let's say this is my 3 by 8. Now for 2, I know it is the same value, so its height will remain the same, just like this, because this is 3 by 8. That's what is 3 by 8. Okay, and for x equal to 3, it is 1 by 8, and this is what is the a. That's the same height for 1 by 8. So this is how you represent your PMF on a bar diagram. Now we will see how we represent CDF on a bar diagram. Now, so far we have defined that our f of x of n is equals to summation of f of x of n, where I is equals to 0 to n. So for f is equals to 0, I know that this will be f0, which is 1 by 8. Now for f at 1, I need to take the values for f of 0, and I also need to account for f is equals to 1. That's because it's starting from 0 to 1. So what is your value for f at 0, which is 1 by 8? And for f at is equal to 1, we know that this is 3 by 8. So this gives you the 1 by 2. Now for f is at 2, now we need to take f0 plus f1 and f2. F at 0, you know that this is 1 by 8, and f at 1 is 3 by 8, and plus f at 2 is again 3 by 8. So we find out that this is my 7 by 8 value. Now similarly, when we work for f at 3, so it will be the sum of f at 0 plus f at 1 plus f at 2 plus f at 3. So when you plug in the values, you will get the value of 1. Now let's draw them on the graph here. So on the x-axis, I have my random variable x. This is 0, let's say. This is 1. This is 2. And this is 3, let's say. So for the 0, I know this is my 1 by 8 value. So again, I go from here. Let's say this is my 1 by 8. For x is equal to 1, I know this is 1/2. So I go like more than this. This is 1/2, let's say. And for f is equal to 2, this is 7 by 8, which is greater than 1 by 2. So I go a little bit higher than 1 by 2. So let's say 7 by 8. And then for x is equal to 3, it should be a straight line actually. So this is my 1, let's say. Okay. So as you can see that every time I'm going next in terms of my CDF, there is an increase in the graph. That's what is the definition of your cumulative functions, because you add a one value in order to find out the next one. Okay. Now one thing I just want to tell you, using the CFT you can also find the PMF. How do you do that? Now this is the definition of F1 and this is the definition of F2. Now if, for example, I know the value of F0 and F1 but I don't know the value of F2, I just take the difference between these two. Okay, so the difference between these two will turn out to be f of 2 minus f at 1. this will provide you the value of your PMF at 2, which is F2. Or if I write down a general formula for this relationship, I can say that f of x of I minus f of x I minus 1, that is equals to f of x of I. Now this is true for I is greater than or equals to 1. Now there are some properties that we need to discuss. Important properties of random variable. The first is the mean value. It is noted by mu, or this is also called as the expected value. Or noted by E of x. Okay. Now, what is the definition of this mean value or the expected value? Mean is measure of central tendency of random variable when a large number of test is performed. Test is performed. Now this is the mathematical definition. Mu is this is also called as the expected value, which is E of x, and that is equals to summation of x of I and f of x of I for all values of I. Now let's apply this on our example that we were doing before. So you know that this is my x value and this is my f of x of I. So for 0 it was 1 by 8. For 1 it was 3 by 8. For 2 I had 3 by 8. For 3 I had 1 by 8. Okay. Now if I want to find out the mean value of this, what I will do, I'm just going to do it here instead of the next slide. So mu is basically is equals to, now I know this is x of I multiplied by f of x of I. So this is my x value and this is my f of x value. So this will be 0 times 1 by 8. Now I know that this is my summation here, so I add up the 1 times 3 by 8 plus 2 times of 3 by 8 plus 3 times of 1 by 8. And when you solve it, you will get your value as the 1.5. That's the mean value or the expected value. Okay. Now the second property is the variance. Variance is the sigma square, or we also write it as the V of X. How we define the variance? Variance is a measure of scatter or dispersion of individual values of X about the mean value or the mu. Or in other words, we can say that it is the variability in the distribution. Now mathematically we define it as variance is equals to, this is the sum of X of I minus mu square times F of X of I. Now if you remember your high school, this is the formula A minus B whole square. So we just open that formula here. So summation of X of I square minus 2 times of mu xi plus mu square into f of x of I Now this f of x of I, we will multiply it inside these parameters. So it will be summation of this value x of I square multiplied the f of x of I minus the summation of 2 mu xi times f of x of I plus summation of mu square, this one, and it is multiplied by the f of x of I. Okay. Now we know that this element here is the constant, so it can come out of our summation. And the similar is true for this. It will come out of your summation sign. So I will have summation of x of I here, f of x of I minus 2 of mu summation of x of I into f of x of I plus mu square and summation of f of x of I. Now this is the definition of the mean we just did before here. This is what is the mean value, which is the mu. So I can write it down, summation of x of I square f of x of I minus 2 of mu dot mu plus mu square. Now this is the sum of the probabilities of the sample space, which is always equals to 1, and it is multiplied by 1 here. Okay, when we further simplify this, we will get summation of x of I square f of x of I minus 2 of mu square plus mu square, and these two terms I can just solve them and I will get minus mu square. So this is what is the sigma square or the variance. So you can use either this formula for variance or you can either use this formula for the variance. Both of them are the same. There's no difference. Now let's see how we solve them. So if you remember your previous example, sigma square is so in terms of our previous example, I can write it down. Sigma from I is equals to from 0 to 3 into xi square f of x minus mu square. Now if you see here, I need to have xi square and then multiplied by f of x. So what I'm going to do here, this is my 0 square times 1 by 8 plus 1 square, this is the value of your x, times 3 by 8 plus 2 square times 3 by 8 plus 3 square times 3 by 8. Okay, I will write it down. Okay, so this is my 0 square times 1 by 8 plus 1 square times 3 by 8 plus 2 square times 3 by 8 plus 3 square times 3 by 8, and then I need to subtract the square of my mean value, which is 1.5 whole square. So when you solve it, you will get the value of 0.75. Okay. There is another thing which is called as the sigma. This is just the standard deviation. Sigma is find out when you take the square root of your sigma square. So for our example, we just find out this is equal to 0.866. So the sigma values turns out to be 0.866 for our given problem. Okay, I'm going to stop it here and I will take your questions.
Yani आपण ihmal deviation genera معیار استاندارد genera معیار کدوم
Last part is, yes, I will upload the lecture for sure. Yes,
من میگم
Oh my lord.
Faith side, could you please ask me the questions?
What is going on?
The last part in the parenthesis is 1/3 and oh yes, thank you for the correction. Yes, this part is basically this is yes, you're right. Yes, I will upload the lecture on the D2. Folks, if you are not asking me the question, I have okay. If you have any questions, you can ask me, please.
Okay. Good evening, sir, from Nigeria.
Yes, sir.
Yes, I can see the. Okay, it has been correct. 1/8. That is what I want to check.
I'm sorry. Yes, I think there's some issue with the signal. Can you please? I could not understand your question. Please ask again.
I said that the probability of that is f of x3. It has just been corrected over there now. I was seeing a 3/8 before, but now it is 1/8.
Yes, it is 1/8. Yes, you're right. Yes. I'm sorry. I just. I also apologize you for my handwriting. Actually, it's just the new device for me, so it will take me time to get it.
It's very okay, sir. It's very okay. We're getting it right.
Okay, thank you. Folks, is there any question?
The slide before that one, where you determine the mean, the actual mean. So those slides are missing because I lost network. I lost network in that slide.
Mm-hmm. That's
the slide before that one. That is the expected value. Right. Sir?
Yeah, go ahead.
I said the expected value, the computation of expected value, which is mean. I lost that side because I have you with network. But I don't know if possible we can still get this material later. Thank you.
Yes, I will share the lecture later for sure. Okay, we have some question here. May you please let me know the reference you suggest for the self-study? Ismail, I have not completed my lecture actually, but the time is run out. So this everything I have I'm doing from the book of the Douglas and the George. It is chapter 3 on page 59. Okay. We have a question from Sabahuddin. He's asking, CDF on the bar graph will always be a straight line? No, it will not be a straight line. So CDF graph basically are something like this. Okay. This is my 1 here. And this is my random variable. Okay. So these are the CDF graph. They're not the straight line. Okay. Now, folks, there is a book of Douglas and George. I will share the PDF file of this book so that you don't have any problem getting it from the library. There is a chapter number 3, page 59. Okay. you need to attempt the examples from 1 to 12. Now, one of the best way to do the example is just don't look at the solution. Do your own example and solve them on your own and see how your solution is different than the solution of the example. So Saim is asking, the textbooks are not available in the library. As I said, I will share it a PDF copy on your D2L. So I will provide you the copy of your textbook. Okay, folks, I'm not done with the lecture actually, but we are out of the time now. So we will start this next thing tomorrow, on Thursday, of course. Is there any more question for me, please? I'm so sorry again for my handwriting. This device is quite new for me and I'm trying my level best to learn it. So just apologize me for my handwriting. It is not that bad, honestly. Is there any more question for me? Okay, so just do one thing. I will upload this lecture today or maximum tomorrow morning. I will try my best to do it today. And just go through this lecture and then try to work on the examples which I share with you 1 to 12 from Douglas and the George book. I will upload the PDF copy of your textbook on the D2L so that you don't have any problem contacting the library, because the library is also closed actually. Is there any more question for me, please? Okay, thank you very much, guys. If you have any question, just drop an email anytime. Thank you and take care. Bye.